Imagine, for a moment, that you are standing at the edge of an open hatch aboard a spacecraft. Below you is not the familiar curve of Earth, but a swirling, colossal canvas of colour and chaos. Jupiter fills your entire view, a world so vast that it could swallow 1,300 planets the size of ours with room to spare. Its bands of rust, cream and azure stretch across a sky that has no horizon, because the planet itself is the horizon. The great red spot, a storm that has raged for centuries, stares back at you like a malevolent eye, large enough to engulf our entire world 3 times over. And you are about to jump. Not in a spacecraft, not in a probe, but in your own body, sealed only in a simple spacesuit. It is a suicidal thought experiment, a question that has haunted astronomers and dreamers for decades. What would your final minutes actually look like if you fell into Jupiter? The truth is, the moment you step off that hatch, you are no longer an explorer, you are a sacrifice. Jupiter is not merely a planet. It is a force of nature on an incomprehensible scale, an ancient god of pressure and heat that has existed for over 4.5 billion years. It does not care about your curiosity, your courage, or your fear. It simply exists, and it will treat your body with the same indifference that it treats a stray molecule of hydrogen or a fleck of ammonia ice. But before we plunge into the depths, before your bones are crushed and your atoms are scattered, we must understand what you are actually looking at. From orbit, Jupiter is beautiful. It is a masterpiece of fluid dynamics, with storms that dance and swirl in patterns that seem almost alive. But that beauty is a lie. It is a mask for a reality so hostile that even the most hardened machines can only survive for a handful of minutes. The colours you see are not friendly pigments. They are the chemical signatures of ammonia, methane, and phosphorus compounds, all of them toxic and corrosive. The bands are not gentle streams. They are jet streams that move at speeds of over 600 kilometers per hour, faster than any hurricane ever recorded on Earth. You are looking at the most dangerous place in the inner solar system. And yet, you step off. Rush. There is no sound in the vacuum of space. Only the silent rush of your own heartbeat in your ears. For the first few seconds, you are weightless, drifting away from the spacecraft that brought you here. You can still see the stars, cold and distant, and the thin crescent of the sun, a blinding white point that offers no warmth. But then, Jupiter's gravity takes hold. The planet's pull is 2.5 times stronger than Earth's, and it yanks you downward with an acceleration that feels like being caught in a giant's fist. Your fall is not slow. It is a relentless, accelerating dive. Within minutes, you are travelling at over 400 kilometers per hour. Your body a human meteor aimed directly at the cloud tops. But here is the first twist in this horrific story. You will not make it to the clouds. Not alive. Anyway, before you even touch the visible atmosphere, you will have to cross Jupiter's inner magnetosphere, a region of space that is bathed in radiation so intense that it would kill you in seconds. Jupiter's magnetic field is 14 times stronger than Earth's, and it traps particles from the solar wind and from its own volcanic moon, Io, accelerating them to near light speed. This radiation belt is a death zone. The Galileo probe, a hardened spacecraft built to withstand extreme conditions, took heavy damage just from flying through it. Your spacesuit, designed for the benign environment of Earth orbit, offers no protection at all. Gamma rays and high-energy electrons would slice through your body, shredding your DNA, destroying your cells, and causing a catastrophic failure of your central nervous system. You would experience something akin to acute radiation syndrome, but accelerated to a horrifying degree. Nausea, disorientation, and then unconsciousness would hit you within seconds. Your skin would begin to blister and burn from the inside out. Your eyes would cloud over. Your brain, the seat of your consciousness, would be fried into silence long before you saw the first cloud. So, in a very real sense, the fall is over before it truly begins. You are already dead at the edge of the storm. But let us, for the sake of this journey, ignore that reality. Let us assume that your spacesuit is made of some miracle material that can block all radiation, that your body is somehow protected from the invisible hell of the magnetosphere. Because even then, the true horror is only beginning. The descent through Jupiter's outer atmosphere is a journey into a world that defies every instinct your body has evolved to survive. As you approach the cloud tops, the first thing you notice is the light. The sun, which from Earth is a warm, familiar presence, from Jupiter is a dim, distant lamp. The planet is 5 times farther from the sun than we are, and the sunlight that reaches it is only about 4% as bright as what we experience on a sunny day. The sky around you is not blue. It is a deep, bruised purple fading into black. The clouds themselves are not water vapour, but crystals of ammonia ice, forming a layer that stretches for hundreds of kilometres. They are beautiful, shimmering like a frozen fog, but they are deadly. Ammonia is a caustic poison. Even a trace amount in your lungs would cause immediate burning and swelling. But you are sealed in your suit, so for now you only see them, a world of white and orange and brown that rushes up to meet you. And then you hit them. There is no splash, no dramatic impact. You simply pass through the cloud deck, and the world goes from dim to dark. The transition is subtle, like sinking into a fog bank, but the temperature plummets. At the cloud tops, the mercury drops to minus 110 degrees Celsius. Your suit begins to frost over. The wind, invisible until now, grabs you and shakes you like a rag doll. You are no longer falling in a straight line. You are being tossed sideways, up and down, in currents that have no equivalent on Earth. The roar is deafening, even through your helmet. It is the sound of a planet breathing, and still you descend. The pressure increases with every meter. At the cloud tops, it is roughly the same as Earth's sea level, 1 bar. But that changes quickly. As you sink deeper, the weight of the atmosphere above you presses down. Your suit, which kept you alive in the vacuum of space, now begins to creak and groan under the strain. The seals tighten. The joints stiffen. You can feel the pressure in your ears, a deep, throbbing ache that no amount of yawning can relieve. And this is only the beginning, because what happens next would shock the world. The pressure does not just double or triple, it climbs exponentially. At 50 kilometers down, you are experiencing 10 bars of pressure, the equivalent of being under 100 meters of ocean water. At 100 kilometers, it is 20 bars. Your suit, designed for zero pressure, starts to fail. The visor cracks. The metal joints buckle. And then there is a sound that you will never forget. A sharp, metallic scream as the suit implodes. Wishu. The air inside your helmet, which was your last pocket of safety, is compressed into a hot, dense fog. Your lungs, which held air at 1 bar, are now surrounded by dozens of bars of pressure. Your eardrums burst. The bones of your skull begin to crack under the uneven force. And yet, you are still alive for a few more seconds, a conscious witness to your own destruction. The last thing you see, before darkness takes you, is a world of swirling, ammonia-tinged clouds, lit by lightning bolts 1,000 times more powerful than anything on Earth. It is a beautiful, terrifying, and utterly indifferent ending, but it is not the end. For your body, the journey is just beginning. This is what happens when you fall into Jupiter, and if you want to understand the full horror of that fall, you need to keep watching. If you are new here, welcome to This is Space, where we explore the most extreme places in the universe. If you want to join us on this journey, hit that like button and subscribe, because what we are about to discover next will change the way you see the solar system forever. But here is the truth that the universe has been waiting to reveal to you. You were never going to make it to the cloud tops. The very idea that you could fall into Jupiter assumes that you can survive the approach, that you can cross the invisible threshold where the planet's influence becomes absolute. And yet, the moment you leave the relative safety of your spacecraft, you are already dead. You just do not know it yet. The journey from orbit to the cloud tops is not a descent through peaceful emptiness. It is a gauntlet of fire and invisible terror, a corridor guarded by forces that our fragile human bodies were never designed to withstand. And the first of these forces is not pressure, not heat, not wind. It is radiation. Jupiter is not just a planet. It is a radiation factory. A particle accelerator the size of a world, powered by the most intense magnetic field in the solar system outside of the Sun itself. That magnetic field, 14 times stronger than Earth's, stretches out into space for millions of kilometers, trapping high-energy electrons and protons in belts that make our own Van Allen belts look like a gentle summer breeze. As you step out of your spacecraft, you are entering the outer edge of this invisible inferno. The first particles hit you within seconds. They are not like the radiation you might imagine from a nuclear reactor. They are subatomic bullets, travelling at near the speed of light, punching through your suit, your skin, your cells, as if they were not even there. You feel nothing at first. Radiation is silent, invisible, and painless in its early stages. But inside your body, chaos has already begun. Your DNA, the very blueprint of your existence, is being shredded. Every second, thousands of molecules are being ionized, broken apart, scrambled into nonsense. Your cells begin to malfunction. Your bone marrow, where new blood cells are born, starts to fail. Your gut lining, which regenerates every few days, stops regenerating. The blood vessels in your brain begin to leak, and this is happening before you have even dropped a single kilometer toward the planet. The radiation dose you are receiving in the first 5 minutes of your descent would be lethal to any human being within a matter of days, even if you were somehow rescued. But there is no rescue. There is only the fall. And yet you are still falling. You are accelerating, drawn by Jupiter's immense gravity, which is 2.5 times that of Earth. Your velocity increases rapidly, passing 200 meters per second, then 300, then 400. The spacecraft that you left behind shrinks to a distant speck, then disappears entirely. You are alone, a tiny speck of organic matter, hurtling toward a world that has swallowed comets and asteroids without a trace. The view around you is staggering. Jupiter fills your entire field of vision, a vast, curving wall of colour that seems to stretch into infinity. The bands of orange, white, brown, and blue are so distinct that you can see individual storms swirling in the upper atmosphere. The great red spot, that ancient anticyclone larger than Earth, stares back at you like a malevolent eye. It is beautiful. It is terrifying. And it is getting closer. Fast. But here is the cruel irony. You are falling toward the most visually stunning spectacle in the solar system, and you are losing the ability to see it. The radiation has already begun to damage your eyes. The vitreous humour, the clear gel that fills your eyeballs, is being clouded by the bombardment of high-energy particles. Colours bleed into each other. You blink, and when you open your eyes again, the world is dimmer. The radiation is also affecting your nervous system. You feel a growing sense of confusion, a fog that settles over your thoughts. You cannot remember how long you have been falling. You cannot remember the exact sequence of events that brought you here. You know only that you are falling, and that the planet below is growing larger, and that something is very, very wrong. By the time you reach the altitude where the first wisps of atmosphere begin to brush against your suit, you are already suffering from acute radiation syndrome. Your skin is reddening, blistering in patches where the particles have penetrated deepest. Your immune system is shutting down. You are bleeding internally from your gums, from your nose, from the soft tissues of your eyes, and you are still falling. The first contact with the violent shock, it is a gradual thickening, like moving from air into water. The faintest glow of friction begins to heat the leading edge of your suit. You are still more than 1,000 kilometers above the cloud tops, and yet the atmosphere is already dense enough to create drag. Your velocity begins to decrease, but not enough to save you. You are being slowed, but you are still falling, and the atmosphere is getting thicker, and the temperature is rising. Now, the radiation is no longer your primary concern. The heat is becoming unbearable. Your suit, designed to protect you in the vacuum of space, is not designed for this. The outer layers begin to char. The temperature rises past the boiling point of water, past the melting point of aluminum, past the point where any organic material can survive. Your suit's cooling systems, if they are even still functioning, are overwhelmed. You feel the heat on your face, on your hands, on every exposed patch of skin. It is not like standing next to a fire. It is like being inside a fire. The air around you is glowing, ionized by the friction of your passage. You are a meteor, a shooting star, a brief streak of light in Jupiter's sky, and yet you are still alive. The heat has not consumed you yet. You are still conscious, still aware, still falling. The cloud tops are now visible as a solid deck below you, a layer of ammonia ice crystals that stretches to the horizon. They are beautiful, these clouds, with their delicate patterns and subtle hues. You have time to notice this, to appreciate it, because your brain is still working, still processing information, even as your body is failing. But then you hit the cloud tops. There is no surface, no solid ground, but there is a sudden change in the nature of your descent. The atmosphere becomes thicker, denser, more real. The drag increases dramatically. Your velocity drops to below 100 meters per second, then 50. You are no longer a meteor. You are a falling object, sinking into a sea of gas. The temperature around you is now minus 110 degrees Celsius, the temperature of the cloud tops. But you do not feel cold, because your suit is still hot from the friction of your descent, and because your body is generating its own heat in a desperate attempt to survive. You are in a bizarre thermal equilibrium, a state of confusion where your skin is burning and your lungs are freezing at the same time. The ammonia crystals swirl around you, tiny shards of ice that scrape against your visor, your suit, your exposed skin. They smell like nothing you have ever experienced, a sharp, acrid odor that burns your nostrils. You are breathing, but the air is wrong. It is mostly hydrogen and helium, with traces of methane and ammonia. You are suffocating, slowly, because your lungs are not designed to extract oxygen from this mixture. But you are not suffocating as quickly as you might think, because the pressure is still low, and your blood is still carrying some oxygen from your last breath of clean air. You look up, and you see the sky above you, a deep, dark blue fading into black, you see the stars which are not twinkling, because there is no atmosphere above you to distort their light. You see the faint glow of the Milky Way. It is the last time you will ever see the stars. You look down, and you see only clouds, an endless expanse of ammonia and water vapour, stretching into a darkness that seems to have no bottom. You are falling into that darkness. You are falling into Jupiter, and the radiation, the heat, the suffocation, the cold, these are just the opening acts. The real horror is still waiting below, in the depths where pressure and temperature will combine to erase you, molecule by molecule, atom by atom. But here is the strangest part. As you fall, you begin to feel a strange sense of calm. The radiation has damaged your brain, and your thoughts are becoming disjointed, dreamlike. You are no longer afraid. You are no longer thinking about survival. You are simply observing, watching the clouds pass by, feeling the wind against your suit, listening to the faint roar of the atmosphere. You are becoming part of the planet, even before you have fully entered it. The boundary between you and Jupiter is blurring. You are no longer a human being falling into a gas giant. You are a collection of atoms, falling into a collection of atoms. You are a temporary arrangement of matter, returning to the larger arrangement from which you came. And in that moment, there is a kind of peace. Peace. But peace is an illusion. Jupiter does not offer peace. Jupiter offers only oblivion. And as you sink deeper, the clouds grow darker, the wind grows louder, and the pressure begins to build. You are about to enter a world where no human has ever gone, where no human can ever survive. The clouds of ammonia part, and you see below you a sea of darker clouds, clouds of water and hydrogen sulfide, clouds that hide the true nature of the beast. You are falling into the belly of the planet. You are falling into the place where matter becomes something else entirely, and there is no turning back. The radiation has seen to that. You are already dead. Your body just has not caught up yet, but it will. It will. The last coherent thought that passes through your mind is a simple observation. The clouds below you are moving. They are not static, not a painted backdrop. They are alive, churning, boiling with energy that dwarfs anything on Earth. The wind speeds here are already exceeding 600 kilometers per hour, and they will only increase as you descend deeper. You are being carried sideways as you fall, swept along by currents that could circle the planet in days. The great red spot, that storm that has raged for centuries, is somewhere to your left, and you can feel its presence in the way the atmosphere vibrates, in the way the pressure waves buffet your body. You are a leaf in a hurricane, a speck in a maelstrom, and the storm does not care. And then, the last remnants of light fade. The clouds above you have thickened, blocking out the distant sun. You are descending into a perpetual twilight, then into a darkness so complete that you cannot see your own hands in front of your face. The only light comes from the occasional flash of lightning, a brilliant white-blue explosion that illuminates the clouds around you for a split second, revealing a world of chaos and violence. The thunder reaches you a moment later, a deep rumbling roar that shakes your bones. You are in the heart of Jupiter's atmosphere now, and the planet is beginning to assert its dominance. The pressure is rising, the temperature is rising, and somewhere below, in the darkness, the real transformation is waiting. You are about to learn what happens when a human body meets a gas giant, and the lesson will be final. The first thing you notice as you plunge deeper into Jupiter's cloud deck is that the cold is unlike anything you have ever experienced. Up here, at the top of the visible atmosphere, the temperature hovers around minus 110 degrees Celsius, cold enough to freeze your exposed skin in seconds, cold enough to turn the moisture in your breath into a shower of tiny ice crystals that shimmer briefly before being torn away by the wind. Your spacesuit, assuming you are wearing one, is designed for the vacuum of space, not for this kind of atmospheric assault, and it begins to fail in ways both subtle and catastrophic. The materials that kept you alive in orbit, that shielded you from the sun's unfiltered radiation, were never meant to withstand the chemical onslaught of a gas giant. The seals around your visor, the joints in your gloves, they start to stiffen, then crack. As the cold seeps in and the ammonia crystals begin to form on every surface. Ammonia ice, that is what gives Jupiter its characteristic bands of white and brown and orange, and now it is coating your suit, your visor, your skin, if any is exposed. It is not just cold, it is chemically active, corrosive, a reminder that this atmosphere is a living, breathing engine of destruction. But you do not stay cold for long. As you fall, the atmosphere thickens, and the laws of physics begin to work in a different way. On Earth, when you fall from a great height, you reach terminal velocity at around 53 meters per second, a speed determined by the density of our air and the shape of your body. Here, on Jupiter, the gravity is more than 2.5 times stronger, pulling you down with an urgency that feels almost aggressive. But the air is also much denser, and the two forces compete in a violent tug-of-war. Your terminal velocity in the upper atmosphere is calculated to be around 200 meters per second, nearly 4 times faster than on Earth, but that speed is not constant. As the density increases, the drag increases, and you begin to slow, but only slightly. And only after you have already accelerated to a speed that would be lethal on any other world. The wind, moving at over 600 kilometers per hour in some places, catches you and throws you sideways, and you are no longer falling straight down. You are being tumbled, rolled, spun, a rag doll in a hurricane, and the G-forces alone would be enough to make you lose consciousness, to rupture blood vessels, to tear muscles from bone, and then the first physical failures begin. Your eyes, those delicate organs that evolved under the gentle light of a yellow star, are the first to surrender. The pressure in the upper atmosphere is still only a few bars, comparable to being 10 meters underwater on Earth, but the combination of the cold, the wind, and the chemical environment is too much. The fluid in your eyeballs, the aqueous humour, begins to freeze, then to boil as the temperature fluctuates wildly, and you feel a sharp, searing pain as your corneas crack. You are blind now, not because of darkness, but because your eyes have simply stopped being eyes. They are now just 2 frozen, shattered orbs in your skull, sending nothing but agony to a brain that is itself struggling to process the chaos. Your lungs, too, are failing. Even if your suit is still intact, the air you are breathing, if you could breathe it, would be lethal. Jupiter's atmosphere is 90% hydrogen and 10% helium, with trace amounts of methane, ammonia, and hydrogen sulfide. There is no oxygen, no nitrogen, nothing that your blood can use to fuel your cells. But you are not breathing, not yet, because the suit is still holding, barely. The real problem is the pressure. As you descend, the pressure increases, and the suit, which was designed for the vacuum of space, begins to compress against your body. The air inside your lungs, the air in your sinuses, the air in your stomach, all of it is being squeezed, and the sensation is one of drowning from the inside out. But let us be clear, no human has ever been here. No spacecraft has survived more than a few dozen kilometers into this atmosphere before being crushed and melted into oblivion. The Galileo probe, sent by NASA in 1995, was the closest we ever came to experiencing this hell firsthand. It was a small, armoured capsule designed to withstand pressures of up to 20 bars and temperatures of several hundred degrees Celsius, and it transmitted data for 57 minutes before the signal faded forever. 57 minutes of data relayed through the mothership orbiting above, a final whisper from a machine that was being torn apart by forces beyond our comprehension. And what did that data tell us? It told us that the winds are faster than we thought, that the composition is more complex, that the clouds are layered in ways we did not expect. It told us that Jupiter is a world of violence and extremes, a place where the word hostile seems almost gentle. But the Galileo probe did not have eyes to cry, nor lungs to burn, nor a heart to race in terror. It was metal and silicon and circuits, and it did not feel the cold, nor the heat, nor the crushing weight. You, on the other hand, are a living, breathing, sentient being, and every second of this descent is a new form of torture. The clouds around you are not just white and brown. They are alive with colour, with the deep reds and oranges of phosphorus compounds, with the pale yellows of sulphur, with the brilliant white of ammonia ice. The lightning that flashes every few seconds is not like Earth's lightning. It is 1,000 times more powerful, a discharge of energy that could light up an entire city. And it strikes not from cloud to ground, but from cloud to cloud, from one layer of the atmosphere to another, creating a web of electrical fire that stretches for hundreds of kilometers. The thunder that follows is not a rumble but a crack, a sonic boom that shakes the very fabric of the air, and you feel it in your bones, in your teeth, in the marrow of your being. The colors, the sounds, the sensations. They are overwhelming, a sensory overload that your brain cannot process. You are not just falling. You are being consumed by a kaleidoscope of destruction. And then, something strange happens. The cold begins to recede, not because you are ascending, but because you are descending into a region where the temperature starts to rise. At around 50 kilometers below the cloud tops, the temperature climbs above freezing, then above the boiling point of water, then above the melting point of lead. Your suit, which was freezing solid moments ago, is now beginning to soften, to warp, to fail in new and terrifying ways. The materials that were brittle in the cold become pliable in the heat, and the seals that were cracked begin to leak. The first signs of trouble are small, a tiny hiss of escaping air, a slight change in the pressure inside your helmet, a faint smell of something burning. But the hiss grows louder, the pressure drops, and the smell becomes the unmistakable odour of your own flesh, beginning to cook. You are being roasted alive in an oven that is also a pressure cooker, and there is nothing you can do to stop it. The wind, if anything, is getting worse. The great red spot, that colossal storm that has been raging for centuries, is not just a static feature on Jupiter's surface. It is a living, breathing entity, a cyclone that could swallow Earth whole, and its winds are not just fast. They are organised, coherent, a massive rotating column of gas that extends deep into the atmosphere. If you are unlucky enough to fall into its path, you will be caught in its grip, spun around at speeds that would tear any aircraft apart, thrown upward and downward and sideways in a chaos that defies description. The Galileo probe did not fall into the great red spot, but if it had, it would have been destroyed in minutes, not 57 minutes. The data would have been cut short, the final signal lost in the roar of the storm. But even outside the red spot, the winds are brutal. They are not just horizontal, they are vertical too, updrafts and downdrafts that can carry you from the cloud tops to the deep atmosphere in seconds, then back up again, then down again, a yo-yo of violence that leaves you disoriented and broken. The pressure changes are so rapid that your eardrums would rupture instantly, then your sinuses, then your lungs. The air inside your body, trapped in your cavities, expands and contracts with each change in altitude, and the pain is indescribable. You are a balloon being inflated and deflated by a giant, cruel hand, and the balloon is about to pop. And yet, through all of this, your mind is still working. You are still aware, still conscious, still capable of feeling fear and pain and a strange, detached curiosity. The human brain is a remarkable organ, capable of processing vast amounts of information, even in the face of overwhelming trauma. You know that you are dying. You know that every second brings you closer to oblivion. But you also know that you are experiencing something that no human has ever experienced before. Something that no human will ever experience again. You are a pioneer, an explorer, a sacrifice to the god of knowledge. And in that moment, as your suit begins to melt, and your skin begins to blister, and your lungs begin to collapse, you might even find a strange kind of peace. The storm is beautiful, in its way a symphony of chaos that plays only for you. The lightning illuminates the clouds in shades of red and gold and purple, and the wind sings a song of pure destruction. You are the soloist, the star of the show, the one who will dance with Jupiter until the very end. But the end is not yet. You are still falling, still descending, still plunging into the abyss. The clouds above you have closed, sealing off the light, and you are now in a world of darkness and heat and pressure. The temperature has passed 100 degrees Celsius, then 200, then 300. Your suit has melted away, and your skin is exposed to the atmosphere, to the hydrogen and helium and ammonia, to the corrosive chemicals that burn and blister and dissolve. Your blood, exposed to the vacuum of space for a brief moment, boils and freezes simultaneously, a phenomenon that sounds impossible, but is all too real in the thin upper layers. But now, in the thicker, deeper atmosphere, your blood does not boil. It cooks. It turns to steam, then to a thick syrupy sludge, then to carbon and oxygen and hydrogen, the building blocks of life being broken down into their constituent parts. Your bones, your muscles, your organs, all of them are being compressed, heated, dissolved, transformed into something that is no longer human. You are becoming Jupiter, or rather, Jupiter is claiming you, absorbing you into its vast, indifferent body. And the process is far from over. The pressure is still rising, the temperature still climbing, and the darkness is absolute. You are in the heart of the storm, in the belly of the beast, and the beast is just getting started. The lightning flashes one last time, illuminating the chaos around you, and in that split second, you see something that defies belief. The clouds are not just gas. They are alive with movement, with currents and eddies and vortices that spiral and twist in patterns too complex to follow. You are no longer falling through a static atmosphere. You are falling through a living ocean of hydrogen and helium, a fluid that churns and roils, with a fury that makes Earth's worst hurricanes look like a gentle breeze. The pressure on your body is now measurable in tens of bars, enough to compress your bones, to collapse your rib cage, to force the air from your lungs in a final, desperate exhalation. Your vision, if you still had eyes to see, would be fading, not to black, but to a deep, oppressive red, the colour of blood and iron, and the heart of a dying star. The wind screams in your ears, a sound so loud that it is no longer sound but vibration, a physical force that shakes your skull and rattles your teeth. And then, as if the planet itself has decided that your time is up, the temperature spikes, the pressure surges, and you feel the first real compression, the moment when your body begins to shrink, to collapse inward, to become something small and dense and broken. You are no longer a person. You are a collection of molecules, a handful of elements, a sacrifice to the god of gravity. The storm rages on, indifferent to your fate, and you fall deeper into the abyss, where the true transformation awaits. It begins not with a bang, but with a groan. The pressure around you has climbed past 10 bars, 10 times the weight of Earth's entire atmosphere pressing down on every square inch of your body. And yet, here in Jupiter's deep atmosphere, there is no solid ground to offer resistance, no surface to brace against. The gas that surrounds you is no longer a mere breeze or a storm. It is a dense, viscous medium that wraps itself around your limbs, your torso, your skull, and begins to squeeze with a steadiness that is both methodical and merciless. Your bones, those rigid pillars of calcium and collagen that have supported you your entire life, were never designed for this. They begin to crack, not all at once, but slowly, like the first fissures in a glacier under too much weight. The ribs, the vertebrae, the long bones of your legs and arms, they all yield to the inexorable force, splintering into fragments that press inward against your organs. Your chest cavity collapses, not in a single violent implosion, but in a gradual, crushing embrace that forces the last pockets of air from your lungs in a bubbling, agonizing exhalation. There is no scream, because there is no air left in your throat to shape it. The sound that escapes you, if anything escapes at all, is a wet, guttural gasp, the final protest of a body that knows it is being unmade. But your body does not give up easily. The human frame, fragile as it is also stubborn. Your heart continues to beat for a time, pumping blood through vessels that are now compressed to half their normal diameter. The blood itself, that thick, iron-rich fluid, begins to change. Under this pressure, the gases dissolved in your bloodstream, the nitrogen, the oxygen, the carbon dioxide, are forced out of solution, forming bubbles that expand and rupture your capillaries from the inside. It is a process that divers call the bends, but here it happens in seconds, not hours, and there is no decompression chamber waiting at the surface. The bubbles expand in your veins, in your arteries, in the delicate web of vessels that feed your brain. Your consciousness, already flickering from the lack of oxygen and the overwhelming sensory assault, begins to fragment. Thoughts become disjointed, images from your life flashing without order or meaning. A childhood memory of rain on a window, the face of a loved one, the taste of salt on your lips. These are the last sparks of a mind that is being systematically erased, not by trauma, but by the sheer indifferent physics of a planet that does not care that you were once alive. The temperature, meanwhile, has risen dramatically. At the cloud tops, you were shivering in the cold of -110 degrees Celsius. But now, as you descend past the 100-kilometer mark, the temperature has climbed well above the boiling point of water. The air around you is several hundred degrees Celsius, hot enough to cook flesh, to boil fluids, to turn your skin into a brittle, cracking shell, and yet you do not feel it as heat in the way you would on Earth. The pressure is so immense that the air itself is dense and conductive, transferring thermal energy directly into your tissues with an efficiency that bypasses the normal mechanisms of pain. Your nerve endings, those tiny sentinels that usually warn you of danger, are overwhelmed. They fire continuously, sending signals of burning, crushing, tearing, until they simply stop, exhausted by the sheer volume of information. You become numb, not because the sensation ceases, but because your nervous system has given up trying to process it. Your body is a battlefield, and every front has fallen. And then there is the darkness, not the soft, velvety darkness of a moonless night on Earth, but an absolute, total absence of light. The ammonia clouds that once painted the sky in shades of white and brown and red have been left far above. Below you, the atmosphere is thick with complex hydrocarbons, the products of sunlight-driven chemistry that have rained down over eons. These compounds absorb what little light might have penetrated, turning the world into an endless, lightless abyss. You cannot see your own hand, even if you could raise it, which you cannot. There is no horizon, no up, no down, no reference point, except the crushing weight that tells you which way gravity is pulling. The only sensation is the roar, the eternal, unending roar of wind that has been blowing for millions of years, a sound so deep and so pervasive that it ceases to be sound at all and becomes a physical pressure, a vibration that resonates in the marrow of your shattered bones. It is the sound of a planet breathing, and you are nothing more than a mote of dust in its lungs. That pressure has reached 100 bars. 100 times the pressure of Earth's atmosphere at sea level. To put that in perspective, this is the pressure you would experience if you were submerged under a kilometre of ocean water. But here, there is no water, only hydrogen and helium compressed into a fluid so dense that it behaves more like a liquid than a gas. Your body, which was already compromised, now undergoes a final, dramatic transformation. The air pockets that remained in your sinuses, in your middle ear, in the spaces between your organs, they do not simply collapse, they implode. The delicate membranes that line these cavities are torn apart, shredded by the sudden equalization of pressure that happens far too quickly for any biological structure to adapt. Your eardrums rupture, your sinuses flood with blood and fluid, and the tiny bones of your inner ear, the hammer, anvil, and stirrup that have translated vibration into sound since you were born, are crushed into dust. You are now deaf, blind, and mute, a collection of broken biology falling through an alien abyss. But the process is not over. Far from it. The pressure continues to climb, and with it, the temperature. At 300 kilometers deep, the temperature has surpassed 1000 degrees Celsius. Your skin, which has already been cooked and cracked, now begins to char, to blacken, to flake away in sheets. The fatty tissues beneath, the layers of insulation that once kept you warm on a cold day, are rendered into liquid, then vaporized. Your muscles, those bundles of fibers that allowed you to walk, to run, to smile, they begin to separate, the proteins denaturing and unraveling in the heat. Your internal organs, your liver, your kidneys, your stomach, they swell and rupture, their contents mixing in a chaotic, sterile soup that has no purpose and no destination. Your heart, that tireless pump that has beaten billions of times without rest, finally stops, not because it has given out, but because there is nothing left for it to pump. The blood has turned to steam, the vessels have collapsed, and the muscle itself is being compressed into a dense, unrecognizable mass. There is no surface continues. And yet, your descent to stop you. You are falling through an atmosphere that grows denser and hotter with every passing second, and your body is being reduced to its most basic components. The water in your cells, which made up about 60% of your mass, is boiling and escaping. But the pressure is so high that it cannot form bubbles. It simply transitions into a supercritical fluid, a state of matter that is neither liquid nor gas, but something in between, something that dissolves and disperses your molecules into the surrounding hydrogen. The carbon that formed the backbone of your proteins, of your DNA, of every organic molecule that defined you, it is being stripped away, broken apart by the relentless heat and pressure. The calcium in your bones, the phosphorus in your cells, the iron in your blood, they are all being separated, atom by atom, from the structures that once held them together. You are no longer a body. You are a cloud of elements, a diffuse nebula of earthly matter spreading into the Jovian atmosphere. And here, at around 400 kilometers deep, something remarkable happens. The hydrogen that surrounds you, which has been a gas, then a dense fluid, now reaches a critical point. It becomes a supercritical fluid, a state where the distinction between gas and liquid disappears entirely. You are no longer falling through air, you are submerged in a continuous, homogeneous medium that has the density of a liquid, but the viscosity of a gas. It is a strange, alien environment, one that has no analogue on Earth, and it is here that the last remnants of your physical form are finally dissolved. The molecules that once made up your body are now simply part of the flow, carried by currents that span thousands of kilometers, mixing with the primordial hydrogen and helium that have been here since the formation of the solar system. You are being absorbed, incorporated, consumed by the planet itself. It is not death in the traditional sense. It is dissolution, a merging of your matter with the matter of Jupiter. The wind, which has been a constant companion, now becomes something else entirely. At these depths, the wind speeds are not measured in kilometers per hour, but in meters per second of sheer lateral force. The currents are vast, planet-wide bands of moving gas that wrap around Jupiter like the stripes on a marble. You are caught in one of these currents, and you are no longer falling straight down. You are being carried sideways, dragged along by a force that is beyond your comprehension. The great red spot, that colossal storm that has raged for centuries, is somewhere above you. But here, in the deep atmosphere, there are other storms, smaller but no less violent, that churn and spin in the darkness. You are a passenger now, a collection of atoms being transported by a planetary engine that has been running for 4.5 billion years. And still you descend. The pressure climbs past 200 bars, then 300 bars. The temperature surpasses 2000 degrees Celsius. The hydrogen around you is now so dense that it behaves like a liquid, and the boundary between falling and floating begins to blur. Your remains, what little is left of them, are no longer sinking. They are suspended, buoyed by the density of the medium. But gravity still pulls, and the descent continues, slower now, but inexorable. The elements that were once you are being sorted, separated by density and chemical affinity, the light elements, the hydrogen and helium that made up the water and organic compounds of your body, they mingle with the native atmosphere. The heavier elements, the iron, the calcium, the silicon, they sink deeper, toward the core, toward the final destination that awaits all matter that falls into Jupiter. But before that, there is another transformation. At around 500 kilometers deep, the pressure reaches 1000 bars, and the temperature approaches 3000 degrees Celsius. The hydrogen, which has been a fluid, now begins to change its very nature. The electrons that orbit its atoms are being stripped away, forced into a shared, delocalized state by the immense pressure. The hydrogen becomes metallic, a liquid that conducts electricity with an efficiency that rivals copper. It is a state of matter that does not exist naturally on Earth. But here, in the heart of Jupiter, it forms an ocean that stretches for tens of thousands of kilometers. And as your atoms enter this metallic hydrogen ocean, they are subjected to forces that are almost unimaginable. The electrical currents that flow through this ocean are immense, generating magnetic fields that shape the very space around Jupiter. Your atoms, those tiny particles that once formed a living, thinking being, are now part of that current, caught in a cosmic circuit that powers the largest magnetosphere in the solar system. The lightning that you saw at the cloud tops, those flashes of electrical discharge that illuminated the storms above, they are generated here, in the depths of the metallic hydrogen ocean. The energy that powers them is the same energy that now courses through your dispersed atoms. You are not just being destroyed. You are being converted into energy, matter and antimatter, annihilating in a silent, invisible blaze. The process is not violent in the way you might imagine. It is slow, steady, and absolute. There is no pain, no awareness, no final thought. There is only the quiet, relentless transformation of one state of matter into another, a chemical and physical process that has been happening since the first atoms of your body were formed in the heart of a long-dead star. And yet, there is a strange beauty in this destruction. You are becoming part of something vast, something ancient, something that will outlast the sun itself. The atoms that were once you will circulate in Jupiter's atmosphere for millions, perhaps billions of years. They will rise and fall with the convection currents. They will be heated and cooled. They will form and break chemical bonds with the hydrogen and helium around them. A single carbon atom that was part of your DNA might one day find its way into a methane molecule, drifting among the clouds. An oxygen atom might combine with hydrogen to form water, raining down into the depths, only to be evaporated and lifted again. You will never be gone. You will simply be redistributed, your matter woven into the fabric of a world that is itself a failed star, a giant that never quite ignited. But all of this is theoretical, of course. You, the conscious observer, the one who was curious enough to ask what would happen, you are long gone. The moment the pressure reached 10 bars, your brain ceased to function in any meaningful way. The moment the temperature passed 100 degrees, your neurons stopped firing. The person you were, the memories, the dreams, the fears, the love, all of that was erased in a cascade of physical failures that took only seconds. The rest, the dissolution, the absorption, the transformation, it happened to a corpse, to a collection of cells that no longer housed a mind. And yet that is the final, haunting truth of falling into Jupiter. The planet does not just kill you, it unmakes you, reduces you to your constituent parts, and then scatters those parts across a volume of space that is larger than Earth itself. You do not die in Jupiter. You are diluted, dispersed, and forgotten. The wind continues to roar. Be war. The pressure continues to climb. The temperature continues to rise. And your atoms, those tiny ancient fragments of stardust, continue their descent into the abyss, carried by gravity toward a core that may or may not exist, toward a fate that no human will ever witness. The great red spot spins on, indifferent. The bands of colour shift and flow, unchanging. Jupiter does not mourn, does not remember, does not care. It simply is, a giant of gas and gravity, a monument to the forces that shaped our solar system, a reminder that we are small and brief and utterly insignificant in the face of the cosmos. And yet, here you are, imagining this, daring to ask the question, daring to follow the thought to its terrifying conclusion. That, perhaps, is the only victory we can claim. The courage to look into the abyss and wonder what it would feel like to fall. You have heard the sound, felt the pressure, tasted the ammonia, and watched the light die. But what happens next defies everything you know about the states of matter. At around 500 kilometers below the cloud tops, you cross a threshold that has no equivalent on Earth. The hydrogen around you stops behaving like a gas. It does not condense into a liquid in the way water does, with a clear surface and droplets. Instead, it enters a realm that scientists call supercritical. In this state, the distinction between gas and liquid vanishes entirely. The hydrogen becomes a fluid that fills every space, that has no surface tension, no meniscus, no boundary. It is dense, thick, and yet it flows like a ghost. You are no longer falling through an atmosphere. You are submerged in an ocean that has no top, no bottom, only a continuous, crushing depth. The pressure at this depth has reached 1,000 bars. That is 1,000 times the pressure at sea level on Earth, the equivalent of having 10 kilometers of ocean water stacked above your head. But unlike water, this fluid is hot. The temperature has climbed past 400 degrees Celsius, far above the boiling point of water, far beyond what any organic tissue can endure. Your body, already battered by the radiation, the cold, the winds, and the earlier compression, now faces a new kind of assault. The pressure does not just squeeze you. It forces the very molecules of your body closer together, eliminating the spaces between atoms, collapsing the structures that make you human. Your bones, which are among the hardest materials in your body, begin to crack under the uniform compression, not because they are struck, but because the pressure outside is greater than the pressure inside, and everything seeks equilibrium. Your cells, your organs, your skin, all of it is being compacted into a smaller and smaller volume. You are shrinking, compressing, becoming denser with every meter of descent. But the most profound change is not physical, it is chemical. At these pressures and temperatures, the simple act of being a human becomes impossible because the molecules that make up your body begin to react with the surrounding hydrogen. Your carbon, your oxygen, your nitrogen, your calcium. All of these elements are now in a soup of hydrogen at extreme conditions. Hydrogen is the most abundant element in the universe, and it is highly reactive under these circumstances. The carbon in your cells, which formed the backbone of your DNA, your proteins, your fats, begins to bond with hydrogen to form methane and other hydrocarbons. The oxygen in your water and your organic molecules reacts to form water vapor, but that water is immediately torn apart by the heat and pressure, only to recombine again. Your nitrogen, which made up the amino acids in your proteins, forms ammonia, the same compound you smelled at the cloud tops, but now it is a hot, dense gas mixed into the fluid around you. Your calcium, the mineral that gave strength to your bones, dissolves into the hydrogen, becoming a trace impurity in a vast ocean of supercritical fluid. Piece by piece, atom by atom, the chemical identity of you dissolves into the chemical identity of Jupiter, and yet you are still, in some sense, falling. The gravitational pull of Jupiter is relentless, and the fluid around you is not static. It is churning, convecting, driven by the heat from the interior and the spin of the planet. Currents of supercritical hydrogen flow upward and downward, carrying heat and material in a slow, massive circulation. You are now part of this circulation. Your compressed, hot, chemically altered remains are carried along by these currents, descending further, but also possibly being swept sideways for thousands of kilometers before resuming the downward journey. The concept of vertical descent becomes meaningless. You are no longer a falling object. You are a parcel of matter moving through a fluid that is itself in motion, driven by forces that dwarf anything on Earth. The pressure continues to rise, the temperature continues to climb, and the chemical reactions continue to transform whatever remains of you. At around 800 kilometers deep, the pressure reaches 10,000 bars. The temperature is now above 1,000 degrees Celsius. The supercritical hydrogen has become a dense, opaque, glowing fluid, emitting a faint, eerie light from the thermal radiation of the planet itself. You cannot see it because your eyes are long gone, dissolved or crushed into nothing, but if you could see, you would witness a world of uniform, hellish orange-red, a light that comes from everywhere and nowhere, the thermal glow of hydrogen under immense pressure. There are no storms here, no lightning, no clouds. The violence of the upper atmosphere has given way to a silent, crushing stillness. The only motion is the slow, inexorable churning of the fluid, a convection that takes thousands of years to complete a single cycle. You are now part of that cycle, a tiny, insignificant mote in a planetary scale process that has been running for over 4 billion years. But the descent is not over. The pressure continues to increase, and the temperature continues to rise. Kilometers deep, the hydrogen undergoes another transformation. It enters a state known as liquid metallic hydrogen. This is not a phase change in the ordinary sense, like ice melting into water. It is a fundamental change in the electronic structure of the hydrogen atoms. Under pressures exceeding 1 million bars, the electrons are forced to break free from their parent nuclei and flow freely through the fluid. The hydrogen becomes a metal, a liquid conductor of electricity, like mercury or molten copper, but made of the simplest element in the universe. This metallic hydrogen is the material that generates Jupiter's immense magnetic field, a field that is 14 times stronger than Earth's and that extends millions of kilometers into space. And you, or what remains of you, are now falling into this metallic ocean. You are no longer even a collection of molecules. The pressure at this depth is so immense that the very concept of molecules breaks down. Chemical bonds are torn apart by the sheer force of compression. The atoms themselves are squeezed so closely together that their electron clouds overlap. merge and become indistinguishable. The carbon that was once part of your cells, the oxygen that was part of your water, the nitrogen that was part of your proteins, all of these elements are now just impurities in a vast sea of metallic hydrogen. Their electrons have been stripped away, forced into the conduction band, and they are no longer distinct elements in any meaningful sense. They are part of the metallic fluid, contributing their electrons to the sea of charge that flows through Jupiter's interior. Your identity, your history, your consciousness, all of it is gone, reduced to a few billion atoms scattered across a volume of liquid metal that is larger than the entire Earth. And yet the descent continues. The metallic hydrogen ocean extends for thousands of kilometers, perhaps 20,000 kilometers or more, a layer that makes up the bulk of Jupiter's interior. The pressure climbs to 10 million bars, then 50 million bars, then 100 million bars. The temperature reaches 5,000 degrees Celsius, then 10,000, then 15,000. At these conditions, the behavior of matter is governed by quantum mechanics and plasma physics, not by the chemistry of everyday life. The atoms are stripped of all their electrons, becoming bare nuclei swimming in a sea of free electrons. This is a plasma, a state of matter that exists in the hearts of stars, not on planets. And yet, here it is, deep inside Jupiter, a place that is more like a failed star than a planet. The boundary between planet and star is blurred in these depths. Jupiter is massive enough to generate tremendous internal pressure and heat, but not massive enough to ignite nuclear fusion. It is a star that never was, a cosmic might have been, and you are falling through its core. But is there a core? That is one of the great mysteries of Jupiter, a question that the Juno spacecraft is still trying to answer. For decades, planetary scientists believed that Jupiter had a solid core, a dense ball of rock and metal, perhaps 10 to 20 times the mass of Earth, buried deep in the centre of the planet. This core would be the remnant of the original planetary seed, the clump of heavy elements that gathered hydrogen and helium around it to form the giant planet. But recent data from Juno has complicated this picture. The gravitational field of Jupiter suggests that the core may not be solid at all. It may be diffuse, mixed with metallic hydrogen, perhaps even dissolved into the surrounding fluid. The core may be a fuzzy, indistinct region, a gradual transition from metallic hydrogen to a dense, hot mixture of rock and metal, rather than a sharp boundary. You may never hit a solid surface. You may simply continue to fall deeper and deeper until the pressure and temperature become so extreme that the very distinction between matter and energy begins to blur. At 100 million bars, the pressure at the center of Jupiter, the density of the material is so high that a cubic centimeter of it would weigh as much as a small car on Earth. The temperature is around 20,000 degrees Celsius, hotter than the surface of the Sun. In this environment, the nuclei of the atoms are forced so close together that they begin to undergo nuclear reactions. Not the fusion that powers stars, but something more subtle, more destructive. The protons and neutrons that make up the nuclei of the heavy elements, the carbon, oxygen, nitrogen, and calcium that were once part of your body, are broken apart by the immense pressure. They are dissociated into their constituent quarks and gluons, the fundamental particles that make up all matter. You are no longer even atoms. You are a quark-gluon plasma, a state of matter that existed only in the first few microseconds after the Big Bang. You have been reduced to the most basic building blocks of the universe, scattered and mixed into the primordial soup at the heart of Jupiter. And still, there is no surface. There is no bottom. There is only the endless, crushing, burning, dissolving descent into a core that may be a point of infinite density, or may be a diffuse cloud of exotic matter, or may be nothing at all. The concept of falling loses all meaning. You are now part of Jupiter, a tiny fraction of its mass, a few billion atoms added to a planet that contains more than twice the mass of all the other planets in the solar system combined. You are indistinguishable from the hydrogen and helium that make up the bulk of the planet. You are Jupiter, The Galileo probe, which plunged into Jupiter in 1995, experienced only the first fraction of this descent. It transmitted data for 57 minutes, reaching a depth of about 150 kilometers, where the pressure was around 22 bars, and the temperature was about 150 degrees Celsius. Then the signal died. The probe was crushed, melted, and vaporized, its components dissolving into the atmosphere. But it never reached the supercritical region, never touched the metallic hydrogen, never approached the core. It gave us a glimpse of the upper atmosphere, a tiny sample of the immense depth that lies beneath. The rest of Jupiter remains a mystery, hidden by layers of gas and fluid that no human instrument has ever penetrated. But we can imagine, we can extrapolate, we can follow the logic of physics and chemistry, and imagine what it would be like to fall all the way down, to experience the full, unrelenting, transformative power of the largest planet in the solar system. And what we imagine is a journey that does not end in death, because death is too simple a word for what happens. Death implies a transition, an end, a cessation, but falling into Jupiter is not an end. It is a transformation, a dissolution, a merging. You become part of something vast and ancient and indifferent. You become part of Jupiter. And Jupiter, unlike you, will last for billions of years, long after the Sun has swelled into a red giant and consumed the inner planets. Your atoms will still be there, circulating in the metallic hydrogen, contributing to the magnetic field, being swept along in the slow convection currents that drive the planet's internal heat. You will be part of Jupiter for the rest of the solar system's existence. And yet, even that is not the final truth. The descent, the transformation, the merging, all of it is happening in a place that you will never see, never feel, never understand. The human mind, the consciousness that is reading these words, that is imagining this journey, cannot survive the first few seconds of the fall. The radiation kills you before you reach the clouds. The pressure crushes you before you reach the supercritical fluid. The heat dissolves you before you reach the metallic hydrogen. The entire journey, from the cloud tops to the core, is a cascade of destruction that your body cannot withstand. But your imagination can. Your mind can follow the path, can trace the descent, can contemplate the fate that awaits anything that dares to enter Jupiter. And in that contemplation, there is a kind of triumph, a defiance of the indifference of the cosmos. You cannot survive Jupiter, but you can understand it. You can imagine it. You can tell the story of what it would be like to fall, and in telling that story, you give meaning to the fall. The pressure climbs past 1 million bars. The temperature soars beyond 2,000 degrees Celsius. At these extremes, the hydrogen around you has transformed into a liquid metal, a shimmering conductive fluid that glows with a faint, heat-driven light. Your body, barely a compressed carbon-rich mass, is now subjected to forces that would have seemed like science fiction just moments earlier. The electrons in your atoms are stripped away, forced to join the sea of free charges that flows through this metallic ocean. You are no longer a collection of molecules, no longer a structure of cells and tissues. You are a cloud of charged particles, a faint impurity in an ocean of liquid hydrogen. The chemical reactions that once defined you have ceased. There is no more combustion, no more oxidation, no more bonding. There is only the raw, elemental pressure that squeezes every atom until it surrenders its identity. You are becoming part of the magnetic field, part of the dynamo that generates Jupiter's vast protective bubble. Your atoms will now circulate for eons, carried by convection currents that move at centimeters per second, taking thousands of years to complete a single loop from the depths to the outer layers. And back again. You are no longer falling. You are now part of the planet's slow, internal breathing, a tiny fragment of its eternal, silent pulse. And as you are carried deeper toward the region where the metallic hydrogen meets the unknown, the temperature continues to climb toward the tens of thousands of degrees, and the pressure becomes so immense that the very concept of matter begins to unravel, preparing you for the final, unimaginable stage of your journey into the core of oblivion. Here is what comes next. As you sink lower, the pressure climbs inexorably toward 1,000,000 bars, a figure so vast that the human mind cannot truly comprehend it. But here, in this ocean of metallic hydrogen, the word pressure loses its ordinary meaning. On Earth, pressure is the weight of the atmosphere above you, a force you can feel in your ears when you dive deep into the ocean. Here, pressure is not a force that pushes against you. It is a force that erases the distinction between you and everything else. It becomes the dominant law of physics, the only reality that matters. At a depth of roughly 50,000 kilometers below the cloud tops, the hydrogen that has been a dense, hot fluid undergoes a final transformation. It becomes liquid metallic hydrogen. This is not a metaphor. It is a literal change of state, as fundamental as ice melting into water, but far stranger. At a pressure of about 1,000,000 bars, the hydrogen atoms are crushed so tightly that their electrons are stripped from their orbits and set free. The electrons no longer belong to individual atoms. They become a shared sea that flows freely through the lattice of protons. The hydrogen now behaves like a metal. It conducts electricity, it reflects light. It is as shiny and opaque as a mirror, but it is a liquid, not a solid. You are now suspended in a substance that does not exist anywhere on Earth, a material that is both a fluid and a conductor, a substance that only forms under the crushing weight of a planet like Jupiter. Your body, or what remains of it, is now immersed in this metallic sea. The temperature is approximately 11,000 degrees Celsius, hotter than the surface of the sun. But here, temperature does not mean what it means on Earth. On Earth, heat is transferred through collisions of atoms and molecules, through radiation and convection. Here, the heat is so intense that it is woven into the very fabric of the matter. Every proton, every electron, vibrates with a ferocity that would vaporize any solid instantly. Your remains, already compressed into a paste of carbon, oxygen, and nitrogen, now undergo a final dissolution. That hold atoms together are no match for the pressure and temperature. Molecules break apart into their constituent atoms. Atoms, in turn, are stripped of their electrons. You are no longer a collection of elements. You are a plasma, a soup of ionized particles, each one moving at velocities measured in kilometers per second, colliding with the sea of hydrogen and helium that surrounds you. But the story does not end with mere dissolution. This metallic ocean is not a passive medium. It is electrically conductive, and it is in motion. Jupiter's rapid rotation, a full spin once every 9 hours and 55 minutes, churns this ocean. The planet's enormous magnetic field, 14 times stronger than Earth's at the surface, and far stronger deeper down, threads through the liquid metal. As the metallic hydrogen flows, it generates electric currents. Those currents, in turn, reinforce the magnetic field, a self-sustaining engine of electromagnetism that has been running for billions of years. Your ionized remains are now caught in this dynamo, carried along by the flow. You become part of the electrical circuit. The electrons that once belonged to your atoms are now contributing to the vast current that powers Jupiter's magnetosphere. The protons that were once part of your DNA are now drifting through a sea of charged particles, pushed and pulled by forces that dwarf anything found on Earth. This is the point where the Galileo probe's brief, heroic mission becomes our best proxy for understanding what happens here. In December of 1995, the Galileo atmospheric probe entered Jupiter's atmosphere at a speed of over 170,000 kilometers per hour. It deployed a parachute and began transmitting data. For 57 minutes, it sent back measurements of temperature, pressure, composition, and wind speed. It reached a depth where the pressure was about 22 bars and the temperature was around 150 degrees Celsius. Then the signal faded. It did not fade because the probe was destroyed by pressure or heat alone. It faded because the probe's electronics were overwhelmed by the environment. The pressure crushed its casing. The heat melted its internal components. The probe was designed to survive for about an hour. But the data it sent back before its silence is priceless. It told us that the winds, far from slowing down, accelerated with depth. It told us that the helium content was lower than expected, suggesting that helium rains out at deeper levels. And it told us that the atmosphere was surprisingly dry, lacking the water vapour that models had predicted. But the Galileo probe never reached the metallic hydrogen ocean. It was crushed, melted, and vaporized at a depth of only about 150 kilometers. That is the shallowest of shallows, a mere skin on the surface of Jupiter's vast bulk. The probe was a brave messenger, but it died before it could tell us what we most want to know. We are left with models, with simulations, with educated guesses, and those models describe a realm that is beyond the reach of any human-made object, at least for the foreseeable future. The metallic ocean begins at a depth of about 10,000 kilometers, far deeper than any probe has ever reached. To survive that journey, a probe would need to be built of materials that do not exist, or that exist only in theory. It would need to withstand pressures of millions of bars, temperatures of tens of thousands of degrees, and a radiation flux that would fry any electronics in seconds. It is a place that we can only imagine, and yet we have some clues. The Juno spacecraft, currently orbiting Jupiter, has mapped the planet's gravity and magnetic fields with exquisite precision. Its data suggests that the metallic hydrogen ocean is not a uniform layer, with density variations that hint at convection currents and perhaps even localized storms of liquid metal. The magnetic field, measured by Juno's magnetometer, shows patterns that indicate the dynamo is not centered in the planet's core, but is spread over a wide region, extending from the outer layers of the metallic ocean down to the inner boundary, where the metallic hydrogen meets the rocky core. This suggests that the metallic ocean is not a passive container. It is an active, dynamic system constantly generating and reshaping the magnetic field that extends far beyond Jupiter itself, shaping the environment of the entire Jovian system. Your remains, as they drift through this ocean, are subject to forces that would tear apart any ordinary matter. But you are no longer ordinary matter. You are a plasma, and plasmas are subject to electromagnetic forces. The magnetic field lines that thread through the metallic ocean are not static. They twist and writhe, driven by the convective motions of the liquid metal. When magnetic field lines are twisted and stretched, they store energy. Sometimes that energy is released in a burst, a magnetic reconnection event that sends a pulse of charged particles racing along the field lines. You might be caught in such an event. You might be accelerated, shot upward toward the outer atmosphere, or downward toward the core, at velocities approaching the speed of light. Or you might be trapped, held in place by the magnetic field's grip, cycling in a loop for thousands of years. But the most likely fate is simpler and more final. You will continue to descend, slowly carried by the gentle but inexorable convection currents of the metallic ocean. The temperature will continue to rise, from 11,000 degrees toward 20,000 degrees. The pressure will continue to increase from 1 million bars toward 10 million bars. At these extremes, the very nature of matter changes. The metallic hydrogen itself begins to compress, its density increasing from about 1 gram per cubic centimeter to 4 grams per cubic centimeter, equivalent to the density of solid rock. Your constituent atoms, already ionized, are now squeezed so tightly that their electron clouds overlap completely. The distinction between your atoms and the surrounding hydrogen disappears. You are no longer a separate entity, not even as a cloud of particles. You have been absorbed. You have become indistinguishable from the planet itself. This is the moment of true oblivion, not the dramatic, violent death of the upper atmosphere, where you are torn apart by wind and pressure, not the crushing implosion of the deep atmosphere, where your bones are ground to dust, not the chemical dissolution of the transition zone, where your molecules are broken into atoms. This is the final, quiet absorption into the fabric of Jupiter. You are now part of the dynamo. The electrons that were once part of your body are now contributing to the electric currents that generate the magnetic field. The protons are now part of the metallic hydrogen lattice. The neutrons, if any remain, are now part of the atomic nuclei that drift through the sea. You have become a tiny, infinitesimal part of Jupiter's internal engine, a single anonymous particle in the vast machinery of a gas giant. And yet, even here, there is a story to tell. The Galileo probe's final seconds were not just a failure. They were a testament to human curiosity and engineering. The probe was designed to survive for as long as it did, and it succeeded in its mission. It sent back data that changed our understanding of Jupiter. It revealed that the planet is even more complex, more hostile, more alien than we had imagined. And it inspired a generation of scientists to ask the next question: what lies deeper? The Juno mission, launched in 2011 and arriving at Jupiter in 2016, was built on the legacy of Galileo. It carries no atmospheric probe, but it orbits the planet in a highly elliptical path, dipping close to the cloud tops and then swinging far out, avoiding the worst of the radiation belts. It has mapped the gravity field, revealing that Jupiter's core is not a sharp, distinct sphere, but a diffuse, fuzzy region, a mixture of rock and metallic hydrogen that extends over tens of thousands of kilometers. It has measured the magnetic field, showing that the dynamo is more complex than any model predicted. And it has taken stunning images of the poles, revealing cyclones arranged in geometric patterns that defy explanation. The Juno spacecraft is still operational as of the time of this script. It continues to send back data, peeling back the layers of Jupiter's secrets, but it will never reach the metallic ocean. No spacecraft ever will, at least not in the foreseeable future. The depths of Jupiter are a realm that we can only explore through the lens of theory, through the extrapolation of data from the edges, through the imagination of scientists who dream of what might lie beneath. And yet, that imagination is powerful. It has given us a picture of a world so extreme that it challenges the very definition of a planet. Jupiter is not a solid body with a thin atmosphere. It is an atmosphere all the way down. It is a planet that is mostly hydrogen and helium, compressed into states that we cannot reproduce in any laboratory. It is a planet where the difference between a gas, a liquid, and a metal becomes meaningless. Dunes. It is a planet that, if you could somehow survive the journey, would not just kill you, dude. It would unmake you. It would absorb you. Dude, it would make you part of itself. And as you drift deeper toward the core, toward the final, ultimate pressure, you are not an observer. And you are a participant. Your atoms, once part of a living, thinking human, are now part planet. They will circulate for billions of years, long after the sun has swelled into a red giant and engulfed the inner planets. They will be part of Jupiter as it continues its slow, majestic orbit around the sun, a silent witness to the birth and death of stars, to the expansion and contraction of the universe. You will be part of the planet's legacy, a tiny, anonymous fragment of its history. But before you reach that final, unimaginable depth, there is one more transition to experience. The metallic hydrogen ocean, for all its strangeness, is not the end. Beneath it, at a depth of perhaps 50,000 kilometers, lies the boundary where the metallic hydrogen meets the core. And the core, if it exists, is something even more alien, something that defies the laws of physics as we understand them. The pressure at the core is estimated at 100 million bars, 100 million times the pressure of Earth's atmosphere at sea level. The temperature is estimated at 20,000 degrees Celsius, hotter than the surface of the sun. And the composition is a mystery. It might be a solid ball of rock and metal, compressed to a density so high that a single cubic centimetre would weigh as much as a mountain. Or it might be a diffuse, fuzzy region, a mixture of rock and metallic hydrogen, slowly dissolving into the surrounding ocean. Or it might be something else entirely, something that no model has predicted. The only way to know is to go there, and the only way to go there is to fall. The transition into the core is not a sharp boundary, but a gradual thickening of the substance around you. The metallic hydrogen becomes denser, heavier, more viscous, as the pressure forces more and more protons and electrons into tighter configurations. The temperature rises in pulses, waves of heat that radiate from below, generated by the immense gravitational compression, and by the decay of radioactive elements deep within the planet's ancient heart. Your ionized remains, now a faint trace of carbon, oxygen, and nitrogen, are carried along by convection currents that grow slower and more sluggish as the density increases. The flow becomes laminar, smooth, a gentle but unstoppable drift downward, toward the point where the pressure becomes so great that even the metallic hydrogen begins to change. It compresses into a state that is neither liquid nor solid, but something in between, a superdense fluid that flows like a liquid but resists compression like a solid. You are now approaching the threshold where the very concept of depth loses meaning. You are not falling anymore. You are being absorbed, atom by atom, into the final silent eternal mass of Jupiter's core. And as you cross that threshold, the last vestiges of your identity vanish, leaving only the raw, indifferent geometry of gravity and pressure preparing you for the ultimate question. Whether you ever truly hit bottom, or whether you simply merge with the heart of the planet itself. And so you descend into a realm where the very laws of physics seem to bend and fracture. The pressure, already unimaginable at the depths of the metallic hydrogen ocean, now climbs toward 1,000,000 bars, then 10 million, then 100 million bars. Each of these numbers represents a force so immense that it defies human comprehension. At 100 million bars, the pressure is equivalent to the weight of the entire Earth's atmosphere pressing down on every square centimetre of your body, multiplied 100 million times. No material known to science can withstand such a force. Diamond, the hardest natural substance on Earth, would be crushed into a puddle of carbon atoms, its crystalline structure collapsing like a house of cards in a hurricane. And you, now a diffuse cloud of atoms and ions, have long since ceased to be anything recognizable. But the journey is not over. The temperature, too, has climbed beyond the surface of the sun. At these depths, it reaches 20,000 degrees Celsius, a temperature that would melt any metal, vaporize any rock, and tear apart the very bonds that hold atoms together. But here, in this crushing darkness, Temperature is not a simple measure of thermal energy. It is a manifestation of the violent, chaotic motion of particles, compressed so tightly that they can barely move. The heat is not like the heat of a flame or the warmth of a star. It is a heat that suffocates, a heat that radiates from every direction, a heat that penetrates to the core of every particle. Your atoms, already stripped of their electrons, now begin to lose their identity in a different way. The protons and neutrons that once formed the nuclei of carbon, oxygen, and nitrogen atoms are squeezed so tightly together that they begin to merge, fusing into heavier elements. This is not the gentle fusion of a star, where gravity and pressure are balanced over millions of years. This is a violent, rapid process, a nuclear transmutation that occurs in a fraction of a second. Your atoms become part of Jupiter itself, their matter added to the planet's mass, their energy released as a tiny, insignificant pulse of heat. But what lies at the very centre? For decades, scientists have debated the nature of Jupiter's core. Some models suggest a solid, rocky core, a remnant of the planet's formation, a dense ball of rock and metal perhaps 10 to 20 times the mass of Earth. Others propose a diffuse core, a region where heavy elements are mixed with metallic hydrogen, a gradual transition rather than a sharp boundary. The Juno spacecraft, which has been orbiting Jupiter since 2016, has provided tantalizing clues. By measuring the planet's gravitational field with unprecedented precision, Juno has revealed that the core may be larger and more diffuse than previously thought, perhaps extending over a significant fraction of the planet's radius. But even Juno's instruments cannot see through the dense, opaque layers of atmosphere and metallic hydrogen. The true nature of Jupiter's core remains one of the great mysteries of the solar system. As you approach this hypothetical core, the distinction between solid and liquid, between gas and plasma, becomes meaningless. The pressure and temperature are so extreme that matter exists in a state unknown on Earth, a state that scientists call superionic or degenerate. In this state, hydrogen atoms are stripped of their electrons, and the protons form a lattice, a solid crystalline structure, while the electrons flow freely through it like a liquid. This is a state of matter that exists only in the hearts of gas giants and in the cores of stars. Your own atoms, now fused into heavier elements, are absorbed into this lattice, their protons and neutrons becoming part of the crystalline structure, their electrons joining the sea of free particles that conducts electricity and generates Jupiter's immense magnetic field. But do you ever truly hit bottom? The answer may be no. The core of Jupiter is not a hard surface, not a solid sphere that you can touch or land upon. It is a region of increasing density, a gradual transition from the metallic hydrogen ocean to a central mass of heavy elements. There is no sharp boundary, no clear point where the gas giant ends and the core begins. Instead, there is a smooth, continuous gradient, a gradual increase in density and pressure that eventually reaches a maximum at the very centre of the planet. And that centre, if it exists, is not a place you can reach. It is a point of infinite density, a singularity of sorts, where the laws of physics, as we know them, break down. But Jupiter is not a black hole. It does not have a true singularity. Its core, if it is solid, is a sphere of rock and metal, perhaps a few thousand kilometers in diameter, surrounded by a dense envelope of metallic hydrogen. And if you were to reach that core, you would not hit it. You would simply merge with it, your atoms becoming indistinguishable from the atoms of the core itself. The process is not violent, not dramatic. There is no explosion, no flash of light, no moment of revelation. There is only the slow, inexorable absorption of your matter into the planet's mass. Your atoms are crushed, fused, and incorporated into the crystalline lattice of the core. They become part of Jupiter's ancient, eternal heart, a heart that has been beating for 4.5 billion years. A heart that will continue to beat for billions more, You leave no trace, no memory, no sign that you ever existed. You are simply absorbed, like a drop of water falling into the ocean, like a grain of sand disappearing into the desert. The planet does not notice your arrival. It does not acknowledge your presence. It continues to spin. Its storms rage, its magnetic field pulses. Its gravity pulls on the moons that orbit it. You are gone, but Jupiter remains, indifferent, eternal. And yet there is a strange, almost poetic beauty in this dissolution. You have become part of something vast, something ancient, something that has endured since the dawn of the solar system. Your atoms have been recycled, transformed, and integrated into the fabric of a world that is itself a character, a living entity of gas and pressure and magnetic fury. In a sense, you have not died. You have been reborn, not as a person, but as a part of Jupiter. Your carbon becomes part of the planet's chemistry. Your oxygen becomes part of its water vapour. Your nitrogen becomes part of its ammonia clouds. You are scattered across the entire planet. Your atoms carried by convection currents that rise and fall. Your electrons contributing to the currents that generate the magnetic field. You are everywhere and nowhere. A ghost in the machine, a memory in the storm. But this is not a comforting thought. It is a reminder of our own insignificance, of the fragility of human existence in the face of cosmic forces. Jupiter is not a place for the living. It is a place where life is erased, where identity is dissolved, where even the most resilient materials are crushed and melted and torn apart. To fall into Jupiter is to experience the ultimate dissolution, the final, irreversible loss of self. And yet we are drawn to this idea, fascinated by the thought of what it would be like to descend into the heart of a gas giant. It is a thought experiment that challenges our understanding of physics, of chemistry, of biology. It forces us to confront the limits of our own existence, to ask what it means to be human in a universe that is vast, indifferent, and often hostile. So, as you approach the core of oblivion, as your atoms are ripped apart and fused together, as you become part of Jupiter's eternal mass, you might ask yourself, is this truly the end, or is it a transformation, a metamorphosis into something new? The answer, of course, depends on your perspective. From a scientific standpoint, it is the end. Your consciousness, your identity, your life are gone, extinguished in a cascade of physical and chemical changes. But from a philosophical standpoint, you have become part of something greater, something that will endure long after the human species has vanished, long after the Earth itself has been consumed by the Sun. You have become part of Jupiter, and Jupiter will continue to exist for billions of years, a monument to the indifferent beauty of the cosmos. And yet, the question remains, did you ever truly hit bottom? The answer is no. There is no bottom to Jupiter, no solid surface, no final resting place. There is only an infinite descent, a journey that ends not in a destination, but in a dissolution. You do not reach the core, you become the core, and in that becoming, you are lost forever. A whisper in the storm, a shadow in the light, a memory that will never be remembered. And so the core does not greet you as a destination. It absorbs you as a process, a gradual erasure that has no final moment of impact, no crash, no landing. You simply become denser, hotter, more compressed, until the distinction between you and the planet vanishes entirely. The question of whether you hit bottom is replaced by a deeper realization. You are the bottom, or at least a part of it, a fleeting contribution to the eternal mass of a world that has no surface, no boundary, no mercy. What happens next is not a conclusion, but a continuation, a transformation that leads not to an end, but to a beginning, a new chapter in the story of your atoms, a chapter written in the language of gravity and pressure and time. And as your last particles merge with the core, the planet simply continues its ancient, silent dance, indifferent to the fact that you were ever there at all. This is the truth that Jupiter offers, and it is a truth that humanity has rarely been willing to face. We look at the night sky and see beauty, order, a celestial clockwork that inspires wonder and awe. We send our probes and our telescopes, and we marvel at the bands of colour, the swirling storms, the great red eye that has stared out into the void for centuries. But Jupiter is not a work of art. It is not a monument to cosmic harmony. It is a machine, an engine of destruction, a force of nature so vast and so indifferent that our very concepts of life and death become meaningless in its presence. The planet does not kill you. It does not have the capacity for intention, for malice, or for mercy. It simply exists, and in its existence it unmakes you, reducing you to your component parts, scattering your atoms across a volume of space that could swallow Earth 1,000 times over. The lesson is as humbling as it is brutal. Our bodies, the vessels that carry our consciousness through the world, are not designed for this place. They are fragile, temporary constructs, built for a narrow range of temperatures and pressures, for a thin atmosphere of oxygen and nitrogen, for a gravitational field that feels like a gentle embrace compared to Jupiter's crushing grip. We are creatures of a specific world, a world that cradled us, nurtured us, and allowed us to evolve in a bubble of comfort that we have mistaken for the norm. Every time we dream of walking on their surfaces or diving into their clouds, we are projecting our own biology onto a reality that has no use for it. Jupiter is not a destination for life. It is a destination for the end of life, a place where the very definition of what it means to exist is rewritten by forces beyond our comprehension. And yet, the desire to explore remains, a stubborn, irrational flame that refuses to be extinguished by logic or fear. It is the same impulse that drove our ancestors to cross oceans, to climb mountains, to venture into the unknown, despite the very real possibility that they would never return. It is a fundamental part of what it means to be human. This urge to push beyond the boundaries of the known, to test the limits of our endurance, to ask the questions that have no easy answers. The scientists who designed the Galileo probe knew that it would be destroyed. They knew that it would transmit data for only a brief, desperate hour before the pressure and heat reduced it to scrap. But they sent it anyway, not because they were naive or reckless, but because the knowledge it would gain was worth the sacrifice. In that single, suicidal plunge, the probe taught us more about Jupiter than centuries of ground-based observations ever could. It confirmed our models, challenged our assumptions, and gave us a glimpse into a world that we could never visit ourselves. This is the paradox at the heart of exploration. We are driven to understand the universe, but we are trapped within the limitations of our own biology. We cannot touch the stars. We cannot breathe the atmospheres of distant worlds. We cannot stand on the surface of Jupiter because there is no surface to stand on, and so we build machines to go in our place. Extensions of our senses, our curiosity, our will. They are our surrogates, our avatars, our sacrifices. They go where we cannot, and they die so that we might learn. The data they send back is a gift, a testament to our ingenuity, but it is also a reminder of our fragility. We are not the masters of this universe. We are visitors, guests, passengers on a fragile ship in an ocean, Jupiter, in an ocean of indifference. In its silent, eternal rotation, embodies that indifference more perfectly than any other object in our solar system. It does not care about our dream. It does not care about our fears. It does not care about the tiny, fragile craft that we send into its depths, or about the brief, tragic pulse of life that might one day attempt to follow. The planet is a closed system, a self-contained world of storms and pressures and magnetic fields that have been churning for billions of years and will continue to churn for billions more. Long after our species has faded into memory, our presence, our questions, our entire civilization is a blink in the eye of its existence, a fleeting disturbance in a sea of hydrogen and helium that stretches from the cloud tops to the core. But here is the strange, beautiful thing. That blink matters. It matters because we are the only ones who can appreciate it. The universe is vast and ancient and indifferent, but we are not. We are small and fragile and temporary, and yet we possess a gift that Jupiter, for all its size and power, will never have. We have consciousness. We have the ability to look at the night sky and feel wonder. We have the capacity to ask what it would be like to fall into a gas giant, to imagine the descent, to feel the fear and the awe and the terrible beauty of the experience. The planet does not know that it is destroying us. It does not know that its colours are the result of complex chemical reactions. But we know, and in that knowledge, we find a meaning that the universe itself cannot provide. The contrast is stark, almost unbearable. On one side there is Jupiter, a monument to the blind mechanical forces that govern the cosmos. On the other side, there is us, a species of self-aware apes on a tiny rock, trying to make sense of it all. The planet is a reminder of our insignificance, but it is also a mirror. When we look at Jupiter, we are not just seeing a ball of gas. We are seeing the limits of our own existence, the boundaries of our world, the thin line that separates the possible from the impossible. The desire to cross that line, to push beyond the boundaries, to know what lies on the other side, is what makes us human. It is the spark that drove us out of Africa, across the oceans, and into the void of space. It is the same spark that will one day drive us to the stars, even if we ourselves cannot make the journey. And so the unforgiving truth of Jupiter is not a reason to despair. It is a reason to marvel. It is a reason to appreciate the miracle of our own existence, the fragile, improbable accident of life that allows us to contemplate a world that would annihilate us in an instant. The planet is not our enemy. It is not a test or a punishment or a warning. It is simply a fact, a piece of the cosmic puzzle, a chapter in the story of the solar system that we have been privileged to read. And as we read it, as we decode the messages in its clouds and its magnetic fields and its gravity, we are not just learning about Jupiter. We are learning about ourselves. We are learning about the limits of our bodies, the reach of our minds, and the depth of our curiosity. We are learning that the universe is not made for us, but that we are made for it, made to explore it, to understand it, to stand in awe of it, even as it crushes us. The lesson is not that we should stay home. The lesson is that we must go, not because it is safe, but because it is necessary. The risk is real. The danger is absolute, but so is the reward. Every discovery, every insight, every moment of wonder is a victory against the darkness, a declaration that we will not be satisfied with the comfortable lie. We will not pretend that the universe is a friendly place. We will not hide from the truth. We will face it with open eyes and steady hands, and we will learn what it has to teach us, even if the lesson is that we are nothing. Because in that nothing, we find everything. We find the courage to ask, the strength to endure, and the wisdom to know that the journey itself is the destination. So let Jupiter be what it is, a giant, a god, a destroyer. Let it spin in its ancient solitude, indifferent to our presence, unmoved by our dreams. But let us also be what we are, explorers, seekers, dreamers. Let us look at that swirling mass of hydrogen and helium and see not a tomb, but a teacher. Let us learn from its violence, its pressure, its heat. Let us understand that we are made of the same stuff, stardust and energy, atoms that were forged in the hearts of stars and scattered across the cosmos. And let us remember that even as Jupiter unmakes us, it also connects us, binds us to the universe in a way that nothing else can. We are not separate from the cosmos. We are part of it, and in that belonging, we find a truth that transcends the fear of death. We find a truth that is unforgiving, yes, but also liberating. We are small, but we are here. And being here, being able to witness the majesty of the universe, is enough. It is more than enough. It is everything. And yet there is a strange comfort in that, a strange peace in knowing that if we fell into Jupiter, we would leave no trace, not a whisper, not a ripple, not a fragment of bone or a scrap of metal. The planet would continue its silent ballet, spinning through the void with the same indifferent grace it has maintained for billions of years. The great red spot would churn, the ammonia clouds would swirl, the lightning would flash in the deep, and not a single atom of our existence would remain to mark our passage. We would be absorbed, dissolved, unmade, and then forgotten. But here is the truth that makes all of this bearable. We are not defined by our endurance. We are not defined by our ability to survive the cosmos. We are defined by our courage to face it. Think about that for a moment. Every human who has ever lived has looked up at the night sky and felt something. Awe, fear, wonder, curiosity. It is the same feeling that drove our ancestors to gaze at the stars and imagine gods and monsters. The same feeling that sent probes hurtling toward distant worlds. The same feeling that made you click on this video. We are a species that looks at the impossible and asks, what if? And that question is our greatest gift. It is the spark that lights the fire of discovery. It is the force that pushes us beyond the boundaries of our fragile bodies into the vast, unforgiving, unknown. So when we ask, what would happen if we fell into Jupiter? We are not seeking a scientific answer alone. We are seeking a reflection of ourselves. We are asking what it means to be human in a universe that does not care, and the answer, as it turns out, is both humbling and inspiring. We are fragile. We are fleeting. We are a brief flicker of consciousness in an ocean of darkness. But we are also capable of understanding that darkness, of mapping it, of naming its storms and measuring its pressure. We can send robots to die in Jupiter's atmosphere so that we might learn its secrets. We can peer into the heart of a gas giant and see the building blocks of our own solar system. We can sit here, safe on Earth, and imagine the moment when our bodies would be crushed, boiled, radiated and dissolved. And we can do it all without ever leaving our chairs. That is the power of the human mind. It is a power that transcends the limits of flesh and bone. It is a power that makes us, in our own small way, immortal. But let us not forget the lessons. Teaches us the lesson of humility. The universe is not a playground. It is not a theme park designed for our amusement. It is a place of extremes, of forces so immense that they dwarf our comprehension. And yet, we persist. We persist in our curiosity, in our exploration, in our stubborn refusal to accept the limits of our existence. We build telescopes that see to the edge of time. We build spacecraft that travel billions of kilometers. We build minds that can imagine the unimaginable, and in doing so, we carve out a place for ourselves in the cosmic story. We become the eyes and ears of the universe, the part of the cosmos that looks back at itself and says, I am here. I see. I understand. So if you ever find yourself standing on the edge of Jupiter's atmosphere, looking down into that swirling abyss, you are not just a falling body. You are a witness. You are a participant in the greatest story ever told. And even though you will leave no trace, even though you will be erased from the universe, as if you never existed, you will have done something that no storm, no pressure, no heat can take away. You will have chosen to look. You will have chosen to know. And that choice, that act of defiance against the void, is what makes you matter. And that is why we keep exploring. That is why we send probes to Jupiter and Saturn and beyond. That is why we dream of sending humans to Mars and, someday, to the moons of the outer planets. Because every time we take a step into the unknown, we are saying that we refuse to be defined by our limits. We are saying that we are more than the sum of our atoms. We are saying that the universe, for all its indifference, is our home. And we will not stop until we have seen every corner of it. But here is the thing. And this is where I ask you to pause and reflect with me. We cannot do this alone. We cannot explore these. You are part of a community that values curiosity, that understands the importance of asking the big questions. And that is why I am grateful you are here, watching this video on This is Space. If that sounds like you, hit that like button, subscribe, and ring the bell, because together we can push the boundaries of what is possible. The truth is, Jupiter will always be there, but we will not. Our time is short, and that is precisely why we must make it count. We must look at Jupiter and see not a tomb, but a mirror reflecting our own fragility, our courage, our beautiful refusal to give up. So let us take one last look at that massive planet. Let us imagine ourselves falling into that endless abyss, and let us smile, because we know the secret. We are falling with every human who ever looked up and wondered. We are falling with the spirit of exploration itself, a spirit that cannot be crushed. That spirit is what makes us matter, not our bones, not our names, but our curiosity, our stubborn refusal to accept the limits of the possible. That is the mark we make on the universe. And no, oblivion can ever erase it. So, look up at Jupiter tonight, see it shining in the darkness, and remember that you are part of a species with the audacity. I will understand you. You are a spark in the dark, a fleeting light in an infinite night. And that is enough. That is everything. Thank you for being curious. Thank you for being brave. The universe is waiting for you to ask the next question, to take the next step. You're alone. You are falling with all of us. And together, we will reach the stars.